Hi everyone, welcome to this presentation on human ambulation, specifically with the goal of reviewing some basics of kinetics and kinematics. I'm creating this presentation for PRF 701, which is our speed, agility, and quickness course, to get everybody kind of up to speed on a couple of concepts. The first part of this presentation is going to be related to some properties of physics. The second part is going to be a review of Gait and the Gait cycle. If you've had PRF 720 already, you've probably learned this information, and this is very much a review. If you haven't yet, then this might be a good kind of setup for what we're going to be learning in 701 related to enhancing speed by improving mechanics during running and improving the ability to apply forces, kind of strategically to get the most out of them. So I wanted to go over some basic physics to give us a better understanding of this. I'm doing this because I will admit I'm a bit of a physics geek and mechanics geek. I really like understanding more about biomechanics, how the body moves, and how these forces are applied by the body to the ground and from the ground to the body. And that's going to be very important for understanding how to maximize human performance, especially when it comes to something explosive like speed. So let's talk a little bit about some basic physics concepts and how they relate to human movement. So let's look at our first group of terms. The terms that I want to go over on this slide are speed, velocity, and acceleration and deceleration. Speed is a simple concept, right? We think of it as how fast you're going, and it is basically in physics going to be defined as a unit of distance divided by time. So how far an object moves over a given period of time. Speed by itself does not have directionality. It's just that. It's how far something moves over what period of time. So miles per hour would be a measure of speed. Velocity is speed, but it also includes directionality. So it's considered in physics to be a vector quantity, meaning it not only has a value, but it also has, or a magnitude, it also has a direction. So velocity is, again, not just a speed, it also includes direction. So that's called a vector quantity. It is typically also measured, velocity, in miles per hour and meters per second, but would also include in what direction the object is moving. And again, typically that's a three-dimensional vector, meaning because we move through space in 3 dimensions. Okay, acceleration and deceleration really are the same term. It's just that we use acceleration when we want to talk about an upward change in velocity. We use deceleration when we want to talk about a downward change in velocity. So these are both vector quantities as well because they also have directionality. Which way are you accelerating? Which way are you decelerating? And again, but they are measures of change in velocity over time. So they're going to be measured by the units miles per hour squared or meters per second squared. So again, a little bit different measurement there. So these are what we're kind of interested in this class, right? If our goal is to get people to run really fast, we not only have to make them fast, we have to make them so they can accelerate to that speed quickly. So again, if I have 2 athletes, one that can get to their velocity, if they have the same maximum velocity, if they both can run at 28 miles per hour, at top speed. If I can get one of them to accelerate to that 28 miles per hour quicker than the other, they're going to be faster, right? So in this course, we're trying to improve not just what the person's top velocity or speed may be, we also want to improve their ability to accelerate. If we're talking about a team sport athlete, we not only want to improve acceleration, right? We want to improve deceleration. How quickly can they stop, change direction, and so on. So in this course, we're very much trying to manipulate physics. So that's why I think it's really important that we understand kind of the concepts behind these terms. Also related to these terms are the terms force and Newton's laws. Do you remember physics from high school or maybe college? Newton, obviously, he's the guy that had the apple fall on his head. He developed a lot of different, very important laws related to forces and how forces affect different bodies and so on. I don't really care that you memorize which one's Newton's first law, second law, third law, but they are really important for understanding how bodies move, how our muscles can affect our body and get us moving in a direction we want to move. So let's talk about Newton's laws and forces. Newton's first law, which is often called the law of inertia, says that an object at rest stays at rest, and an object in motion stays in motion with the same speed and same direction, unless they are acted upon by an unbalanced force. So if we want to talk about a sprinter and they're standing on the blocks, so they basically are an object at rest, right? The only way we can get them to move, to get that sprinter to move and to move quickly, is to apply an unbalanced force. So we have to apply a force in a particular magnitude and in a particular direction to get them to move. The best sprinters are going to be able to apply massive forces in the direction that we want, specifically to the finish line, right? So again, Newton's first law tells us that forces are required to get an object moving, and that greater forces are going to cause greater levels of acceleration and end with greater total velocity. So forces are basically going to have to act upon a body to get it to move. Forces are another physics construct. Forces have a magnitude and a direction. Therefore, they are a vector quantity like we talked about before. So when a force is applied to a body that's going to accelerate the body in that direction, a greater force is going to accelerate the object in that direction even faster. So with training, what our goals are is to improve the athlete's ability to produce force. That means we're trying to make an athlete be able to produce larger forces in the appropriate directions. So when we're strength training and we're doing a lot of that type of stuff, we're making the muscles stronger, which is going to improve the magnitude of force that a person can produce. When we do our form training and so on, we're going to improve their ability to apply the force in the direction we want. When you watch people run, and if their mechanics are off, you see their legs are splaying out to the sides, that means they're applying force, but not directly ahead of them towards the finish line. So we're losing a lot of that magnitude of force in a direction against the direction that we really want them to go. So again, this Newton's first law really helps us in terms of understanding, again, how our training, both training the mechanics of running as well as working on force production, is going to impact sprint speed. Remember too that force is basically mass times acceleration, and we're going to learn more about why that's important here on the next slide. So Newton's second law tells us that the acceleration of an object is proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of an object. So this builds upon the first law, right? The first law, the law of inertia, says the thing's not going to move until we apply a force. The second law gives us even more information. It says the acceleration of that object, when we apply a force upon it, is proportional to the magnitude of the net force, the direction of the net force, and inversely proportional to the mass of the object. So if we think of this again of a sprinter at the starting blocks and the gun goes off, the fastest sprinter is going to be the one that can produce the largest force, can put that force in the direction of the finish line or wherever the target is, and the advantage is going to go to the object that weighs the least. So can we change these with our athletes? We certainly can, right? We can alter the magnitude of the net force that a person applies with their muscles by making the muscles stronger, by making the muscles more powerful so they can produce that force more quickly. We can change the direction of the net force by improving their mechanics and making sure that they're directing all of their force production straight ahead, that their arms are pumping straight towards the finish line, not out to the sides, and so on. And then finally, we can change the mass of the object. This may be harder than with some athletes than others, but we can have them reduce maybe excess body mass. We can give them lighter shoes, lighter clothing, etc. So again, this may be harder to manipulate, but this is also an important factor. Again, if the force magnitude and the force direction is equal, the lighter object is going to end up going faster. So we certainly can change these things with training. We can take anybody and make them faster. We maybe can't make them a world-class sprinter, but anybody can improve their speed if we can improve any or all three of these concepts. So again, Newton's second law really is the key to enhancing speed performance from a physics perspective. Newton's third law, I'm going to talk about as well, maybe less important than the second law, but Newton's third law is that for every action, there's an equal and opposite reaction. This is most important when it comes to sprinting, when we talk about ground reaction forces. When I'm running, I hit the ground with a certain amount of force. Well, if the earth doesn't just give way, the earth pushes back. That's Newton's third law. For every action, there's an equal and opposite reaction. So if I hit the ground harder, then the ground pushes back at me harder. So if you've read the article that I assigned or pointed out in week 1 by Peter Weyand, you'll see why that means that people who hit the ground harder, sprinters that hit the ground harder, also end up running faster, because not only do they hit the ground harder with their foot, but then the ground pushes back harder on their foot and allows them to accelerate more quickly and therefore run at a greater speed. So that's Newton's third law. So anyway, these three laws posed by Newton, especially the second one, I think really gives us some insight as to what we're doing when we're training our athletes for sprinting, when we're trying to make them faster, whether that be faster straight ahead or a team sport athlete where we're trying to get them to be able to decelerate, accelerate quickly, we need to improve their body's function so they can take greater advantage of these laws of physics.